Hello, everyone, and welcome to Lab Manager's Tech Trends webinar series. My name is Trevor Henderson, Technology Editor for Lab Manager, and I'll be moderating today's discussion, which will focus on managing your data. Today we have a panel consisting of 3 experts in the field who have joined us to discuss some of the latest trends in data management. We like our webinars to be very interactive, so we encourage you to send us your questions at any point during the presentation, and the panelists will address these during the question and answer session to follow. To ask a question, simply type your query into the Q&A box located at the bottom left-hand side of your screen. We'll try to address as many questions as possible during the question and answer session, and if we happen to run out of time, I will forward any unanswered questions to the panelists and they can respond to you via email. Additional resources may be accessed via the Filed folder icon, which is located at the bottom of your screen. You may also move or resize any of the windows simply by grabbing them at the top or stretching them at the bottom right corner. At this time, you may need to move or minimize some windows to see the live view. This webinar recording will be available early next week on Lab Manager's website, and at the end of this webinar, we'll share that link with you, as well as the contact information for all of our panelists. With that, let me introduce our first speaker, who joins us today from Agilent Technologies. Alex Leontiev joined Agilent Technologies in May of 2014 as Product Manager for Agilent's OpenLab ECM. Alex has over 27 years of experience in IT solutions and over 15 years in product and software development, management, sales, and support. Alex is currently based in Santa Clara, California. Thank you for joining us, Alex.
Thank you, Trevor. Hello and good day, everyone. On behalf of Agilent, I welcome you and thank you for taking time from your busy day to attend this session. I am here to talk to you about OpenLab ECM, Enterprise Content Manager. OpenLab ECM is Agilent's flagship scientific data management solution offering. Before getting into the specifics of ECM, I will first establish a context in terms of 2 frames of reference: different classes of users and their requirements addressed by OpenLab ECM, and the broader OpenLab software suite, which includes ECM. So let's begin with the review of the user groups and the requirements who have really helped to in the genesis and evolution of OpenLab ECM. As you might expect, the primary group of users is the lab analysts, our friends at the front line. This is where all the action starts and takes place. Usability and accessibility are primary considerations for our busy analyst colleagues. As an analyst, my primary goal is to efficiently get the job done. Eliminating or at least reducing paperwork is one effective way to achieve this. Next are lab managers who look beyond individual instruments or projects. As a manager, I want to maximize productivity. Looking across the entire lab landscape, I'm continually looking for opportunities to make informed decisions that enhance business value and contribute to the bottom line. Rounding out the different groups of constituencies are our friends in the IT and procurement departments. Colleagues in this camp are primarily focused on the infrastructure. Ensuring the integrity and security of data infrastructure are paramount. The ultimate goals are to mitigate risk and to optimize investment decisions. Centralized management is a time-tested model that can help obtain these goals and in the process realize cost savings. So now let's take a look at the OpenLab software suite. Anchoring the portfolio is the instrument control offering OpenLab Chromatography Data System, or OpenLab CDS for short. Some of you know this product and may have actually even used it. OpenLab CDS is where data collection as well as processing begin and is the primary source of analytical data. Next member of the software suite is OpenLab ECM, which is the focus of this session, and I will be talking or covering this in a lot more detail shortly. And the third and final offering under the OpenLab banner is the experiment management product, OpenLab Electronic Notebook, or OpenLab ELN. Both OpenLab ELN as well as OpenLab CDS are integrated with OpenLab ECM and use it as their centralized backend repository. Collectively, these three components serve the three constituencies we just reviewed and enable your entire organization to extract information from the sea of data for fast and optimized decision making. One last portfolio-related consideration is the two complementary products associated with OpenLab ECM, those being OpenLab Intelligent Reporter and OpenLab ECM Business Process Manager. The names are pretty self-explanatory. OpenLab Intelligent Reporter is a sophisticated reporting engine used for cross-sequence and cross-project reporting as well as trending analysis. OpenLab BPM is a process engine that is used to automate and streamline workflows, especially as related to document review and routing. This is particularly useful in the context of compliance. So now let's focus on OpenLab ECM, and we'll start that by taking a look at its benefits. In the lab environment where analytical data are generated, a primary advantage of OpenLab ECM is the centralized repository model, which enables efficient and uniform access. These are achieved by having a single place where user roles and associated access rights are defined and maintained. OpenLab ECM also automatically tracks changes and creates new versions of electronic records as new data arrive. And finally, OpenLab ECM keeps a detailed log of activities, who did what, when, and why, along with electronic signatures. Ultimately, OpenLab ECM weaves the complex web of analytical data along with business processes into a cohesive solution that is particularly useful in regulated environments. This centralized model of OpenLab ECM addresses many of the user requirements we just covered. Enhanced usability for the analyst, productivity gains realized by streamlined business operations for the manager, and a reliable means to manage data infrastructure that can save on operational IT costs. But there is more. A central repository which can be accessed from outside the lab has additional benefits. An important and an obvious one is the luxury of being able to conduct analytical processing and reprocessing from the comfort of your office. By providing flexible search and retrieval tools, OpenLab ECM makes this possibility a reality. And by extension, collaboration is realized when analysts and managers can share data and reports and other content in the ECM repository. This is how OpenLab ECM addresses the remaining requirements of ease of use and optimized business processing. Now let's have a look at the capabilities of OpenLab ECM. Data archiving is the foundation. OpenLab ECM has automatic and manual means for collecting and storing data into the central repository. Note that analytical data collection from non-Agilent data systems is supported. Further enhancing the process are filtering and metadata extraction capabilities that are used for subsequent search and retrieval. By combining report generation and capture along with electronic signatures and detailed activity logs, OpenLab ECM facilitates the process of compliance and reduces its overall cost to your organization. In addition to analytical data, OpenLab ECM can store and manage a variety of other data types. Prime examples being Microsoft Office, Adobe PDF, and large binary files like images. Metadata extraction is possible with PDF files, which is a powerful mechanism for workflow automation. Lastly, OpenLab ECM is integrated with a variety of Agilent and non-Agilent applications. Specific to analytical data systems, we already covered OpenLab CDS. The Agilent mass spectroscopy data system, known as Mass Hunter, is also integrated. And you can also see examples of non-Agilent data systems that are supported with OpenLab ECM, Empower, and Chameleon. And there are many more. Beyond analytical data systems, OpenLabs ECM is also integrated with a number of ELN and LIMS products in the market. I will next put all these components and capabilities into a high-level architectural type diagram to help you visualize and ultimately better remember various aspects and benefits of OpenLab ECM. So let's break this architecture down to its main components. To the left are instruments which serve as the primary source of analytical data. As discussed, a variety of Agilent and non-Agilent data systems are integrated. There are mechanisms in place to enable integration of virtually any type of instrument. To the right is the other major source of content for your OpenLab ECM repository, non-instrument data which are just as important as your analytical data. Virtually any kind of digital data can be uploaded to the OpenLab ECM repository. And some of the more popular formats like PDF can be processed with add-on filters to extract metadata. Having collected all these data in your OpenLab ECM Data Hub, which is in the center, you can advance to the workflow automation and comprehensive reporting stage. At the bottom of the slide, you see the various user communities who access the Data Hub via web-based interfaces. A sidebar on the two types of network access depicted on this slide, intranet and internet. The purpose of showing both these types is to convey a final benefit of OpenLab ECM, which is its scalability. Smaller organizations can realize all the benefits we've talked about just as easily as large enterprises. Smaller deployments typically rely on a local intranet-based model. Larger enterprises with operations spanning the globe can realize the same benefits by tapping into the powers of the internet. And by the way, as examples for the two types, especially for the large-scale enterprises, we have deployments that involve thousands of users and manage hundreds of terabytes of data. So we've covered a lot of ground, and let us conclude by doing a recap of what we just reviewed. The main takeaway you want to have is that OpenLab ECM can manage and organize all your electronic content regardless of the source or type, be it analytical data coming from instruments or any other data type, electronic reports, PDF files, Microsoft files, and what have you. And there are add-on capabilities, reporting, business process management that can help you then take full advantage of these data and derive information from it. I invite you to visit our site, which is mentioned on this slide, or contact me at any time you have any questions. Thank you, and Trevor, back to you.
Well, thank you, Alex, and thank you all for sending in your questions. I encourage you to continue to do this throughout the presentations. And if you're joining us late, you may ask questions simply by typing your query into the question box, which is located at the bottom left-hand side of your screen. Our next speaker today is Jason Troxell, who joins us from Ruro. Jason took his background in biochemistry and computer sciences to launch into 15 years of impact-filled work with FDA-regulated development environments. Throughout his career, Jason has successfully pushed companies towards more efficient SDLC and related quality processes. Joining Ruro in 2014, Jason quickly established effective directorship of all quality activity. Mr. Troxell is a hands-on leader for the software provider, drawing daily from his spectrum of skills, including requirements analysis, training, test case validation, and other quality documentation authoring and review. Jason is currently managing Ruro's efforts to become an ISO 9001 certified company. Welcome, Jason.
Thank you, Trevor. Much appreciated. Okay, I'd like, on behalf of Ruro, to thank everyone for taking time out of their schedule to join us today. For people that might not know, Ruro is a small LIMS provider. We are located in Frederick, Maryland. 7 or 8 years ago, we initially started focusing on sample management software solutions. And over the past 3 to 4 years, we've been offering a LIMS product called Infinity. And we have deployments in business areas ranging from translational medicine to biobanking to next-gen sequencing. What I'd like to talk about today is our vision for how to handle data management and in a true fashion of merging data and process management together. Okay, so first, talking about data management and why we believe companies are looking for this, companies are collecting a wide amount of data, across many different business areas, many different laboratories if we're focused in the life sciences, and this data tends to be very disjointed and siloed within the different organizations. So, with data management, companies are hoping to pull that business critical information in, achieve more efficient data binding, get more value out of their data, maybe even improve the efficiency of their operations. The things that hamper this, though, is that the data, from these different groups are typically collected in different tools. The different groups within the company are going to be using typically different terminology, different data definitions, and all this results in very fragmented and disjointed data that is, not conclusive to data mining. So what Roro envisions for this and a way to go about trying to improve this is to integrate process management with data management. So what we're envisioning here then is that we can combine the procedures that are being performed within a company with the data that is being generated. And when we do this, we start giving the data more context and we start making the data more organized. Things that we think will companies will gain by this is that you start enforcing your company procedures. We start reducing the chance for procedural errors when data is being collected and entered. Additionally, we can enforce workplace quality standards better. This can be done by data validation during the different processes that are being performed. And, as an added benefit, because we're now merging the data with the processes, we have the opportunity for management to have more visibility into, what their group is doing, how efficient the operations are being performed. So what I'd like to talk about next is exactly how this works. And Roro offers a solution. Our Linfinity product is called Linfinity. And I'm not seeing my slide. There we go. There, now we have it. Our product is called Infinity, and we have a two-step process in deploying our system. So the first is defining the data model. And when we talk about the data model, we are talking about the data that a company wants to collect. We're looking at the general entities. If it was a biobanking solution, we want to talk about maybe files, maybe patient information, specimen storage, whatever it is. And then on top of those subjects, we want to talk about the data that is actually going to be, the actual data will be collected for those subjects. So this is, an excellent opportunity when we start talking about doing these data models to focus on data standardization. The definition process should include all the different groups, or at least a representative from all the different groups in the process, so that everybody is having their input and everybody is agreeing on the terminology and the data that's being collected. So as a process of doing this now, we essentially define what we call the static relationship between the data elements in the system. And this is really the foundation. Once you get your data model right, it's much easier to put everything else on top of it. The second part of our process then is actually defining what we call workflows, or the processes that your company is doing. In Linfinity, we define workflows as a series of states, and those states can be connected, however is appropriate for your lab. And within those states, each state essentially represents a part of your procedure, and it can be dependent on the group that's performing it, or a set of functions that are appropriate for that a single state. States can have tools assigned to them, and for Linfinity, Roro offers a toolbox, standard toolbox, to achieve these typical functions that are required within our system. However, all those tools are completely customizable by scripting, really to support almost any type of functionality that a lab would require. For our perspective, workflows make the data more dynamic. If the data is the what, the workflows become the how. Okay, so moving on to the next part here then, let's give an example and put this in the context a little bit. So we're going to consider as an example now a biobanking solution. And in particular, we'll focus on the sample acquisition process. And let's say that the sample acquisition has the following steps associated with it. So there would be an initial request or a submission along with an approval of that submission. And then we would go ahead and send this out to vendors and receive vendor quotes, and then select a quote, generate a purchase order. And then once the purchasing process is completed, we would generate an incoming shipment. And then once that shipment is in the system and being tracked, we can receive electronic data for any samples that are incoming and import those into the system so that everybody's aware of what is going to be coming. Finally, we receive the shipment, we physically check the samples in and assign them to storage positions. So all of these processes can be defined as individual workflows. And depending on how much detail there is in your process, these could be broken down into even more workflows than the 6 I identified here. It just depends on the needs of your group. The important part here is because these are configured to your specification, the workflows are aligned with your lab's procedures. This allows us to have the data validation piece that you might need to ensure quality. If there is required information that you want entered into the system, then we can make that required in the system, and you're not allowed to proceed until that information has been entered. Again, data is going to be collected at defined points in the process, and we would aggregate in our system all that data in the workflow becomes aggregated and associated to a data object specific to the workflow. An additional benefit here is even though these are all under individual workflows, we can link the workflows together. And this ends up now allowing your data from the very initial part of this process to be linked all the way through the purchasing piece, all the way through the incoming shipment, and all the way down to the actual check-in. Okay, so with that, we now see where we can start integrating data management and process management. And what we think is really powerful about this is that we've now linked this critical data and made it visible from the beginning to the end. This allows us to do searching over the entire range of activities that the data is associated with. So, for example, just to think about this, now we have the ability to go and, for example, if there's a submission and they want to confirm the samples have been received, you have the ability to start at the very beginning of the submission, see the samples that were associated with it at the time that the purchase was made, and then verify that those samples are now in storage, received and in storage. Or you could envision a person in the laboratory that's been working with one of these samples, and they're starting to run low and they need more for additional experiments that are being performed. So you can go back into the system, you could retrieve the vendor quote and determine what vendor it was that provided these samples, go back to that vendor directly, determine if the vendor has more samples. If they don't, you can see other quotes that were collected for the same submission that have the same properties associated with them, and go to those other vendors and again see if they have samples available for you. And this is something that probably would have been very difficult in other systems where you would have an independent purchasing process. Maybe the submission process through purchasing is separate from the check-in and the actual storage and what the laboratory is dealing with. So it just gives you this visibility that might not have been possible otherwise. Okay, let's step up a little bit, step back, and talk about the requirements for data management system. I've been talking specifically about Linfinity, but we believe that there are some important products here, or features that you should be looking for. So first, with the large complex companies that we're dealing with nowadays, it's critical to be able to support concurrent users across multiple locations. The whole point of this data and process management integration would be lost if people couldn't share data across sites and access the same data. Along the same thoughts, flexibility for this system becomes critical. We know that there are lots of highly specialized products out there for very specific activities that are happening within a company. And those products obviously really facilitate a specific purpose. But when we're trying to integrate all of this different data with the processes across an entire company, these specific tools, I believe, lead to the silos, the data silos that we're trying to avoid. So selecting a tool that's very flexible, that can be extended across a wide number of domains, is going to really facilitate preventing that problem. However, we know that all these groups are already using their own tools, and this is part of their daily operations. We don't want to impact that. So having this flexible tool, being able to integrate with third-party applications, is also going to be highly critical for success of one of these projects. So that's certainly a feature that you want to look at. Once you have all this data and it's linked in your system, having a strong search engine that's flexible and powerful is going to make it able to do the data mining that you're looking for. So having searchability is obviously a key feature. Another aspect of having all this data aggregated in one place now is that your security and your permissions become much, much more critical. So you want data to be restricted only to people that's appropriate for. People in the lab might really only want to be able to see data relevant to what it is that they're doing and maybe some things that are upstream from them as appropriate. Whereas, the management level might want to obviously be able to see the data for all the different groups so that they can monitor what's happening, their efficiency, and then maybe they need to have access to the finance information or whatever is appropriate. It also becomes very important when you start thinking about patient data, that you have very tight control over who has access to that sort of data because it's very sensitive. And then the other piece that we want people to think about strongly is, for the data, for the business that you're in and the data that you're collecting, what are the appropriate compliance and regulatory standards? And driving into this just a little bit, we typically deal with the life sciences, and things that we're often dealing with in an FDA-compliant environment is, for example, validation. If your system needs to be validated, then you want to make sure that the vendor that you select and the product they're working with, has a strong quality system, that there is a strong software development lifecycle procedure that's been defined and is being followed. If you're working with electronic records, then 21 CFR Part 11 compliance is important. You can have electronic signatures. If you have a lot of patient data and access to that is a concern, then HIPAA compliance is also a factor. So again, when evaluating vendors, just make sure that you're factoring this into your system, or their quality system into your evaluation. Okay, and the last thing, just to talk about briefly, is when you're evaluating these systems, how do you go about hosting them? And the part that we think is interesting, there's the historically, way of doing it, where you have an IT group and you have your own infrastructure and everything is hosted internally. And obviously now the cloud has become more of a player in these systems. But I know from conversations that we've had with customers, there's a lot of hesitation about going to the cloud. People are aware of the benefits. You can lower your IT costs because you need fewer personnel and you don't have to have dedicated hardware. Another benefit is that you can have these mirrored instances set up to give you data redundancy. This allows you to ensure maximum uptime of the system. It also gives you a very viable backup recovery plan for in the event of a disaster. The other obvious advantage of the cloud is it's scalable. So you can start with a small, lower computer processing system in the beginning. As you bring in more groups, as you're accumulating more data and have more users, you can scale up. So that's something, again, that can be very challenging to do on your own systems. However, the part that we at Wuro think is exciting is, we've been working with at least one vendor in particular who is very focused as a cloud-hosted system in being FDA compliant. And this is something that we are looking to offer to customers and bring them onto because we think it, really facilitates, the compliance that companies are looking for and giving them the assurance that they can keep a validated system in an FDA-regulated environment. Okay, so, I pretty much have covered what I want to talk about here. In conclusion, Wuro, again, believes that merging process management with data management is going to give the benefits that companies are really looking for, as they're looking to implement data management throughout their company. When you're looking at the systems and evaluating them, it's really critical for a successful deployment that you identify both the right solution and the right vendor. So make sure you're, understanding what your requirements are and really assessing your vendors against them. And then finally, as you're looking at how to host those, keep in mind now that there are viable cloud options that are FDA compliant that really should, make more and more companies consider a cloud-hosted system going forward. And with that, I will turn it back to Trevor. Thank you very much.
Great, thank you, Jason. And just a reminder that all of our speakers have kindly provided additional resources, and these can be accessed via the file folder icon, which is located at the bottom of your screen. Our final speaker today, joining us from QIAGEN Bioinformatics, is Rupert Yip. Rupert was a postdoctoral fellow at the Howard Hughes Medical Institute at Harvard Medical School before joining the ranks of the industry. In the past 15 years, he was a management consultant for a Big Four firm, bioinformatics product manager at Life Technologies, Illumina, and several startups including Bina Technologies. Currently, he is a director in product management at QIAGEN Bioinformatics. Thank you for joining us today.
Thank you, Trevor, and thank you for having the opportunity to talk about next-generation sequencing, big data management. First, I'd like to frame the discussion by talking about some of the next-gen sequencing, NGS informatics challenges. A lot of customers who are embarking on an NGS capability for their lab face tremendous challenges with regards to data storage and distribution. So things like the vast amount of data that's generated by these sequencing machines, as well as how to deliver these results to their customers, either locally or globally. Additionally, data management is one aspect, but bioinformatics capability is another challenge. Customers are always asking core labs for more analytics and more data analysis capabilities, and then hiring and retaining bioinformatics talents is a challenge. Also, customers, which are specifically scientists, are always changing and evolving their scientific investigations. So one day they may be doing DNA-seq, and the next they may want to follow up with RNA-seq or MET-seq and so forth. And then finally, let's not forget the hardware and IT costs underneath all of this to maintain the bioinformatics capabilities, as well as the storage of these sometimes petabytes of data. So when we look across the landscape, there are expert labs who are very good at the wet lab and generating the raw data, and then that's where they end. They just deliver the raw data and expect the customer to do something with the data. Then there are advanced labs who not just generate the raw data, but also do the alignment and variant calling, but really don't do anything in terms of what the data means. And finally, there are really leader labs that do the entire portfolio of data generation as well as data interpretation. And where customers see value is the more towards the data interpretation is where they're more willing to pay money to get that information. And really the data interpretation is where the rubber hits the road, where you'll really understand what mutations and what diseases that individual may be harboring. So for those of you who are familiar with the QIAGEN brand, you'll know of QIAGEN as the blue and red boxes that have the reagents, the high-quality reagents. What you may not realize is that QIAGEN, in the last couple of years, has acquired a bioinformatics capability, and they did that by acquiring several companies, including Ingenuity Systems, DLC Bio, and BioBase. And as a result, it's really become a leader in bioinformatics. Just to give you some numbers, the bioinformatics offerings that QIAGEN provides is broadly adopted. For example, my product, Ingenuity Variant Analysis, has had over close to 400,000 human samples uploaded and analyzed. Our entire portfolio has already produced over 30,000 scientific publications. These are peer-reviewed publications using our bioinformatics tools. And we actually have an army of MDs and PhD who read the scientific literature and gather the corpus of human knowledge and have put together a content database of mutation findings that are over 3.5 million findings. So how does QIAGEN Bioinformatics provide solutions to these NGS challenges? Well, for data storage, we offer a secure hosted, privately hosted service with virtually limitless storage and compute power so that you don't have to build that infrastructure yourself. As a result, you can also deliver the VCF files through this hosted service so that you don't need to ship hard drives around the country or around the world. Our bioinformatics capabilities means that it's user-friendly bioinformatics, and our self-service model allows the customer rather than the lab to do the analysis so that you can focus on what you want to do and allow customers to focus on doing the science they want to do. As customer demand evolves, we have flexible workflows to match those evolving needs. And it is our job really to keep up with the state of the art so that you don't have to. And then finally, because of our secure privately hosted service, it's really a turnkey solution that allows you to essentially outsource the hardware layer and IT capabilities to us and let us lower your total cost of ownership for providing this service. So let's first talk about one of the products, which is Biomedical Genomics Workbench. What Biomedical Genomics Workbench does is it takes the raw FASTQ coming off of the sequencers, such as the Illumina HiSeq. Those FASTQ files are then processed. There are pre-canned workflows so that you don't need to build these pipelines. They're already there for you. QC reports to make sure that the runs coming off of the instruments are of high quality. And there's an audit trail so that you're able to see how all of that data is analyzed and under what parameters were used to generate the data. And then finally, a visualization and validation tool allowing you to go back and check to make sure that those reads that you're getting off of the instruments are of high quality. Once you've generated the VCF file, which is the variant calling file, the variant calling file really identifies what are the mutations that are present in that individual. And if you imagine a typical individual who has around 4 to 5 million mutations, all these mutations are really a big data challenge. How do you understand which mutation is responsible for the disease or the phenotype that is observed in that patient? Well, variant analysis is a tool that allows you to just ask simple questions about the 4 or 5 million variants. So one question you might say is, well, let's remove low-quality variants that are found in this 4 to 5 million. So you easily remove a few there. The next thing is remove common variants. Common variants are, for example, variants that occur in a healthy population that are unlikely to contribute to disease. And then the next is show me only those variants that are known in the scientific literature to cause pathogenicity. And so you're down with less. And then finally, show me only those variants that are related to the phenotype that I'm observing in my patient. And so you're left with very few variants. And then variant analysis really provides a way so that it's very easy for you to find the scientific evidence to back these findings. How do we do that? So here's a typical workflow where on the left you've got that filtering down to very low numbers of variants. The table in the middle shows you that short list of variants. And on the right you can click more details. We hook into proprietary databases such as the Human Genomic Mutation Database, and you click on that and you can pull up the information for that particular mutation. Further, you could find all the scientific evidence, basically the corpus of knowledge around that particular mutation at your fingertips. And then finally, if you have any disease indications or phenotypical information, we have what is known as pathway to phenotype that shows you how that mutation relates to the disease or the phenotype that you're observing in the patient. So all this is done without any command line, and your customers, the scientists, can do this on their own, and it's a completely self-service model. So what are some of the benefits of partnering with QIAGEN Bioinformatics for your NGS core lab needs? Well, as I've mentioned, we offer a low or zero cost option to power up your bioinformatics. It really is a turnkey solution that provides your lab with a bioinformatics capability virtually overnight. We have 24/7 customer support to walk not just you, but your customer through the bioinformatics analysis. And through our secure privately hosted platform, you no longer need to ship hard drives around the world. You just need to send the link out by email to your customer, and they can receive the results right away. And once you start offering interpretation services, NGS interpretation services as part of your offering, you can actually upsell and charge more for your offering. But don't just take our word for it. We've already signed up with a couple of prominent core labs or service providers. In March of this year, we signed up with GATC, which is a leading European service provider. And then a few months later, we signed up with BGI, which is the world's largest sequencing service provider in the world, to partner with QIAGEN Bioinformatics for their customer. Now with that, I also want to switch gears about another big data challenge, which is population genetics. And one of the biggest challenges with understanding a disease is how do you know that this disease is not a polymorphism for a particular ethnic group or whatnot. It's similar to the experience that a doctor with 50 years of experience versus a doctor with only 5 years of experience, and how the veteran physician is able to identify whether a mutation is noise or real. And so using the allele frequency community, which is something we've set up, allows people to donate their genome sequences to calculate allele frequencies to know the prevalence of a particular mutation within a certain population. This is a free service to all users, and it really has the power to reduce the noise in the data, where you can start generating error models and removing the noise from the signal. So I want to summarize by coming back to how we frame the challenges with data storage. We have a secure, privately hosted solution that makes it very easy to store the data and deliver data to your customers. We offer a bioinformatics capability that allows you to power up and offer bioinformatics to your customers, what we call FastQ to Insight. And using a combination of our biomedical workbench and variant analysis really allows either you or your customer to get to an answer, a biologically relevant answer, much faster. And then for those customers who have evolving customer demands, we offer a flexible commercial-grade bioinformatics platform so that you don't have to worry about tweaking and updating pipelines. And finally, we offer a very low-cost, even zero-cost way for you to begin offering bioinformatics to your customers. And with that, I'll hand it back to Trevor.
Great. Thank you very much, Rupert. And again, thanks to all our presenters today. I think we'll go directly into our question and answer session. We do have a number of questions that have come in from the audience. And the first question I have is, what can labs do to minimize the risk and impact of informatics errors? And I'll throw that out to whoever would like to chime in on that.
Perhaps if you're a little more specific about what type of errors they're referring to?
Well, I think they're perhaps, interested in ensuring data quality and reliability overall. And how do these solutions ensure good data quality?
Well, so for NGS data, there is a large challenge with respect to data quality, and our genomics workbench really has the tools to allow you to look at the spectrum of the quality information of the reads that are coming off of the instrument. So our tool already provides that capability. Many of the NGS tool sequencers also provide tools for auditing quality information. But if you're talking about other aspects of quality, then perhaps Jason or Alex can comment on sort of regulatory quality information.
Yeah. Actually, yes, thank you. I was about to jump in and say the kind of quality you were just talking about, it covers from the application perspective. From a repository perspective, it's a much more generic view on data quality, and in particular, really, it's data integrity. And to that, with OpenLab ECM in particular, Data integrity is ensured primarily by way of utilizing technical controls. Prime example being checksums. That's how we make sure that not only data integrity is preserved, but that's also the mechanism we use for tracking when there is a revision to data being made. So that's kind of the technical perspective or technical control perspective, I should say, on data quality and really related to that integrity.
Sure, and if I can pitch in from Aurora's perspective, I would say that we would probably focus on the procedural side. Looking at that, we would rely on the instrumentation that we were integrated with, to ensure that the data was of certain quality, and then we can enforce that the proper procedures are followed, and if there's appropriate data validation that we can put into our scripting, we can certainly support that as well.
Great, thank you. Now, when we talk about multi-vendor integration, how is this implemented and who provides the support for this?
Let me take that one on because I think that's kind of something that came up in my part of the presentation. So
I think so.
Yes. So in the context of content management, multi-vendor support is definitely one of the big challenges. In Agilent, and in particular with OpenLab ECM, we do offer a number of add-ins that we've actually developed, and we test them rigorously. Now, beyond that, we also provide the same building blocks that we've used for providing those add-ons that we provide, and those being an SDK, a software development kit, as well as a UDK specifically designed for the filtering capabilities. And then, on top of that, we provide the mechanism that I alluded to for automatic upload of data by setting rules such as arrival of files in a particular location, for example. Combining the scheduler capability that I just described along with filtering that either is provided as part of the product or that can be developed, you can pretty much put those two building blocks together and then achieve support or integration of data, I should say, with any kind of instrument with OpenLab ECM.
Thank you, Alex.
Anything to add, James? Well, so from Aurora's perspective, we have a fully capable API that will support many different types of integrations. But one of the advantages of a small company like Aurora is we would certainly entertain, if there was a desire for third-party integration that we didn't support already, the customization of our software and our framework to support that. That's something that we definitely welcome and would entertain.
Great, thank you. Now, how frequently should a lab be reviewing their informatics solutions?
Well, I'll take a crack at that one again.
Sure.
From especially a regulated environment. Primarily, it's a balancing act. Change is the only constant, right? That's that old and tried cliche, but it's very true. And ultimately, what one needs to do is look at the impact of that change. And so, for instance, in the context of ECM, we do provide very frequent and periodic updates to the software, and that can actually trigger some angst. And to facilitate that decision-making process in terms of whether or not a qualification or a validation is needed, we provide what we call impact analysis reports. So anytime there is a software update that we have ready for our customers, there is an impact analysis that our customers can review and for themselves decide whether or not it's time for a qualification or revalidation.
Okay, thank you. Any other additions to that?
Trevor, can you repeat the question for us?
It was how frequently should a lab be reviewing their informatics solutions?
Okay. The only thing I'll add, I'm not sure whether the update process was what was being referred to, but we can in Woro and our configurations, we certainly have the ability to add, review processes into any of the workflows. So, the frequency, we would rely on a laboratory, and whatever regulations they're trying to comply with or policies that they have to identify that. One of the things that we do have is the ability to run, we call them scheduled scripts in the background, which would allow an automatic review, for specific cases that we could flag errors and send out emails, to notify people that they need to go in and review the data for certain situations.
Okay, thank you. Now, our next question, I think, is directed again at you, Jason. Now, does the Woro system, does it take care of off-pattern data automatically?
Not necessarily. So we have the ability during any of our imports when data is being entered to do data validation, against any rules that you would want to define. We typically do not attempt to correct data. We generally would notify you of, anything we identified that seemed unusual or didn't meet the rules. But we have generally found with our customers that, there is a preference, that they have, a manual addressing of any, data issues that are identified.
Okay, thank you. Now, our next question asks, if a system is being revalidated as a result of an upgrade, can that system be used during the validation process?
I'll answer that very quickly. Our preference is typically to handle the system updates in a non-production environment initially. So we would apply it to a user acceptance testing site where we can do the validation, show that everything is appropriate, is working as expected, and then switch. We generally with the cloud-based deployments, we can just switch the database to look at the new instance, and that way you're always working in a validated environment. So I think there's a definite compliance risk in trying to use a non-validated system.
Yeah. And I would echo that answer as well as it applies to OpenLab ECM. Similar to what I just described, we also typically our customers rely on a test environment in which new updates, let's say, or any changes are first tested before deploying into the production environment, and therefore you definitely mitigate risk as it relates, especially in regulated environments.
Great, thank you. Now, are there any prerequisites that you would recommend before storing data in the cloud?
I guess, when we deal with companies, it usually comes down to, I don't know if risk adversity is the right question, but, when you start talking to their quality and regulatory groups, what their perception of the cloud is. So if you have a very, traditional company, it's a big sell to tell them that, it's safe to move up to the cloud, that, we can put adequate security in place, that your data is going to be in a validated system. So that's really, I think it typically comes down to, your regulatory and quality perceptions within your company.
Yeah, and I will complement that answer by saying also, again, I would tie it back to the motivator behind making a move to the cloud. That's where I would start. Excuse me. What I mean by that is, for instance, an organization that's working at the forefront of research and they have some very sensitive IP to protect versus other operations that are more regular, ongoing, such as production type. Definitely very different types of requirements and different concerns that are associated. So I would look at cloud security, for instance, in the context of the application and the data that's being considered for being moved into the cloud.
Yeah, and I'll also jump in here. The experience that I've seen is, especially for human data, patient data, it's important that you find a cloud provider who is HIPAA compliant as well as PHI compliant. And then in Europe, there are additional requirements. There are privacy and safe harbor requirements. And then you might also want to check with your institution's IRB requirements to see if sending data outside the firewall of the institution is something that is allowed.
Great, thank you. Well, we've reached the end of our questions today, so I'd like to thank you for the discussion. And this brings us to the end of today's webinar. If you have any further questions, please reach out to our experts. Their emails, as you can see, are on the screen now. And just a reminder that today's webinar video will be available at the link you see on the screen. On behalf of Lab Manager, I'd like to thank our panelists today for all the hard work that they put into their presentations. And I'd also like to thank our sponsors, Agilent Technologies, Ruro, and QIAGEN Bioinformatics, for supporting our Tech Trends webinar series. Additionally, I'd like to thank all of you for taking time out of your busy schedules to join us today. Please mark your calendar for our next Tech Trends webinar, which will focus on new developments in material testing. This webinar will be taking place Thursday, July 16th from noon until 1:30 p.m. Eastern Daylight Time. For more information on this and other Lab Manager webinars, please visit our website at www.labmanager.com. We hope you can join us again. Thank you and have a great day.